Welcome back, episode 5. Mr. T here. In this episode, we are going to start controlling the camera. So it probably, I know we would think it would make sense to start designing this 3D mini golf hole and actually start designing the level, so to speak, and get a hole in there to shoot at and start keeping track of our strokes, get some UI. But really, we don't have anything right now to follow the ball as we shoot. So it really quickly, if this was a bigger hole, not this little square, we would shoot and the ball would be off camera. So we need to set up our camera following first. Now, I initially started to do this in Cinemachine and I was having some success, but as I wanted to add 3 different functionalities to the camera, I could not do it with Cinemachine, all 3 at the same time. I was able to do 1 at a time, but I wasn't able to implement all 3. So it was a little bit beyond my scope. So I had to pivot off of that and decide to just create my own script that would be affecting this camera directly. We might bring in Cinemachine later on, but for now, I don't think it's, we really don't need it, and this script works great. So let's get into it. Before we're going to do this, just to give you a bit of an idea, I want, first of all, when I shoot the ball here, the camera needs to follow the ball, and I'm going to add a slight damping effect to smooth that out. If you don't add damping, it can get a little bit crazy when it's following the ball and gets choppy, and it doesn't look very good. The second functionality is to kind of being able to zoom in and out. Right now, that's just changing the scale of my view right now, but I want to be able to zoom in and out. And we're going to have the ball slightly off-centered. Okay, so I'm just going to reset this ball where we had it before. So let's just grab the ball here. So we're going to set that to 0. And so right now you can see the ball is relatively dead center on our screen, but I'm going to slightly offset it just down in this region here so we can see a little bit more ahead of where we're shooting. Okay, and we're going to be doing that as well. So the other 2 functions, other than following the ball when it's moving with a slight damping, is I'm going to be able to hold the right mouse button to rotate the camera. You're going to need that to see where you're shooting the ball from time to time. You'll be able to do that before you shoot and while the ball is moving if you like. And also a third functionality I thought would be cool is the scroll wheel easily zooming in and out. It's not it only takes a couple lines of code really to do, and I thought it was a cool function to add. So we're going to be using everything on the mouse, left mouse, right mouse, and the scroll wheel in this video, in this 3D mini golf. So before we do that, we got to add a few things to the ball. So let's do that right now. So on our ball, I want you to right click and you're going to be doing create empty. You're going to call this the pivot. We need this in order to match the pivot, the rotation of the camera. This pivot is acting like a fulcrum or a pivot to rotate the focal point, which I want you to create another empty child. So we have a child of a child here. We're going to be calling this the focal point, and that's where our camera is going to be focusing on. And I'm just going to move this slightly in front so we can zoom in here. I'm going to be moving this slightly in front. So I want you to go to your Z and set it to 4. Okay, so we're just going to move it slightly in front, and that's going to allow us to see a little bit in front of where we're shooting. So now that we have that, let's go to our main camera. We're going to add component, and of course we're going to be adding a new script called camera controller. So create that and add. Make sure you name it the same as me, camera controller, all one word with capital C's, and once the script loads up, we'll get to coding. Hasn't opened yet. Let's try opening again. There we go. Okay, we got this empty script here. We actually won't be using the start method here. We could use it for initializing some of our variables, but we're going to use the inspector for that. So we're going to be making, I think, about 7 private floats here. So follow along with me. So our first private float, it's going to be called the sensitivity, and we're going to set that equal to 2f. Okay, that's going to be the sensitivity of our mouse when we're rotating our camera. Okay, and the next one that we want to grab here is going to be called so another private float, and we're going to call this distance. This is going to control the distance our camera is from the focal point. Okay, so we're going to set that to 30f initially. Next, we're going to be setting up some boundaries. So when we're using our roller wheel, we can't zoom in too far or too close. So we're going to set some min and max distance. So first the min distance, we're going to be setting that to 20f, and then we're going to do the same thing, public float, this is going to be the max distance, and we're going to set that equal to 50, which is definitely far enough out. You won't need to go any further than that. We're going to quickly set up a private float to store our scroll input. Okay. We don't need to set that. We're going to be updating that in the update method. And then we're going to need to have a zoom speed. So another private float, and like often when we get an input, we're going to control it with another float, and this is going to be the zoom speed, so how fast the camera zooms in and out. And I found a setting of 5 worked best for that. Sorry, let's make sure that's 5F being a float. Okay, and then now let's set up our damping. So the higher this number, the faster the camera catches up with the rigid body it's following, or the game object. And I found the damping, so we're going to call damping, looked pretty good at 5. Now you might disagree with that, but we want everybody to have the same values, and I think it worked out pretty good. Looks good in the end, so you'll see it soon. The private float, that is the last one we need, is going to be called the yaw. So yaw is a term that's the horizontal rotation, so we're going to be rotating around the y-axis of our focal point technically as we start to change our camera angle. Okay, now we're going to need to store those, the ball, the pivot, and the focal point. So these are all going to be public transforms. So first one's just going to be called our player. The next one is going to be called our pivot. And the third one is going to be called our focal point. Focal point. Okay, just a couple more variables here. We're going to need a private vector 3, and we're going to call that the target position. This is going to be what we use for our damping effect, so that we have a target position to lerp to. I'll explain that's short for interpolation. And next we're going to have a public reference, because we're going to need to get a little bit of information from the golf ball controller script on our ball. Okay, that's it. Now we're all set up, we're ready to code this. So most of everything we're going to be doing is in the update function here. So first thing first, I'm going to add a little comment here so we can kind of organize our thinking. We're going to be adding the zoom function. Okay, so we're going to be doing that first, and then later on hit enter a couple times. We're going to be controlling, this will be the rotation of camera portion. We're going to be putting that later on in the update, and then we're going to actually, the last thing we're going to do, I think in the update still, if I remember correctly, oh yeah, update the target position. Okay, so those are the different things we need to be doing in here. And we're going to be first working on the zoom portion. Okay, so first we're going to update our scroll input here. Whoops, scroll input, and we're going to set that equal to the input dot get axis, and this axis has a very specific name, so please make sure you spell it correctly. Mouse with capital M, space, scroll, wheel, no space, but with capital S, capital W. Okay, so please be careful when you get that information from your input of your scroll wheel. And then we're going to set up a simple little if statement that just checks if the scroll wheel has been moved. So we're going to set scroll input if it is not equal to 0. If it's not equal to 0, meaning it's not turning, this will say obviously we are turning the wheel, so we need to update the distance of the camera. So we're going to take that distance variable and we're going to go subtract equals. I'll explain how that works in 1 second. scroll input, and then multiply that by what we were designing was the zoom speed factor of how fast the camera will zoom. So what's happening here with this, it's just a short form way. This subtract equals, you can do plus equals, multiply equals. What this is saying, it's taking the variable distance, and what this says is it's saying equals distance subtract this. So it's just a shorter way. Like I could code it like this and say distance subtract, but the short form way, if I want to update the value that that I'm declaring here, that I'm utilizing, I can do it much faster by just doing subtract equals. Okay, so that does the exact same thing. So that's going to update my distance value, and I want to clamp it. So in case the player is trying to go further back or closer than they're allowed to, I'm going to stop that using mathf.clamp. And it actually knows exactly what I want it to do. I'm going to take that value of distance and I want to clamp it between the min distance and the max distance, which we declared up above. Okay, that's the scroll wheel function. It's not going to do anything yet. You notice we're not changing the transform in any way of our camera yet. So let's actually first update the rotation of our camera. So we're going to do that right here. And of course, this is going to be an if statement checking if the right mouse button is held down. So this chunk of code will continue to run in the update as long as we are holding down the mouse button. And this one has an index of 1 for the right mouse button. Okay. So now with the right mouse button held down, we're going to be setting up a quick float called mouse X, because this is going to just grab the input of the movement of our mouse while holding the right mouse button left and right as we slide left and right in the X-axis direction. So we're going to set that to input dot get axis. And this get axis is called, make sure you do it in quotes, mouse space capital X. And remember, we're going to multiply this by that sensitivity value, so that's going to help control a little bit faster on this input. Otherwise, it would rotate really slow if we didn't up the sensitivity on that. Okay, now we're going to use this input to change the yaw value. So yaw in this, we're going to go plus equals, kind of like before. It's yaw equals yaw plus what? Well, we're going to just add on this mouse X variable. There we go. All right, so now we've updated the yaw, but now let's actually rotate the camera. So I'll put in, I don't need spaces there. There we go. Okay, so let's actually update the camera here. So transform dot, we're going to be updating the Euler angles. The Euler angles is the rotation of our camera. So we got to be setting up a new vector 3 to do this. And so Euler angles allows me to do it in degrees. Now I want the angle for my x-axis to always be 40. Okay, that's that slight tilt down, looking down on our ball. We don't want to change that. So that's our x value. Next, we're going to put in the yaw value. So this is the rotation on the y-axis, which is what we want. And the z we're not going to change. So just leave that as 0f. Okay, so that's going to rotate the camera. We also, remember we created that pivot. The pivot, Euler angle, we need that to rotate as well, because if we rotate the pivot, because the focal point is a child, it will rotate the focal point around the ball. Now, you might say, well, why didn't we just make the ball the pivot? Well, if I rotated the ball, if we add a texture like a dimpled golf ball, or maybe you make it look like a soccer ball, or whatever texture we end up using or material, I didn't want that to happen. It didn't make any sense. We want the ball to spin freely as it normally would, so it looks better in the game. So we made this pivot to control it inside of the ball. Okay. And so the pivot Euler angles, we're doing the exact same thing, except I don't need the 40 degrees. And again, new vector 3, I don't need the 40f. I need to just make sure the x stays 0. I don't need to rotate on that, but I do want the yaw again to match the rotation of our camera to rotate the focal point. This way, everything will line up nicely. Yeah, and the z again is just going to be 0. Okay, so now let's actually update the position of the camera. Finally, transform.position, and we're going to update that. And how we're going to do that is we're going to be moving this transform position based off of getting the direction first of between the two vectors. To get a direction, you subtract them. So focal point dot position, and we're going to subtract the transform. Now, not the position of our camera, but we want the forward value. That allows us to always be in the direction the camera is facing, which is forward in 3D space. It's in that blue vector. So, and that will get us the right direction, but that's normalized that forward. So we're going to need to multiply it finally by that value we got before, the distance. So that way it'll pull the camera back the same amount as we control it with the scroller wheel. Okay, and that's all we need to do inside that if statement. That's going to rotate our camera. Next thing, just outside of the update here, we're going to update the target position. This isn't going to be an if statement this time. We're just going to be applying this even if I want to update the rotation here, the transform Euler angles, and then we're going to be storing this. So we're doing this in case the right mouse button isn't held down, and I'll explain that. So I'm actually going to take this line here and this line here. We're going to copy both of those, because this is what we're going to be using to actually help us follow the ball. So I'm going to be updating both of these again. Now, of course, the yaw isn't changing if I'm not holding the right mouse button, but I want to put this in the update because I need to store this in the target position. So the target position now is equal to the focal point position. And again, we're going to be subtracting the transform dot forward, and we're going to multiply that by distance. Now, the whole reason I'm doing this is because now I'm going to be opening up a method we've used before, and that's the fixed update. So private void, and we're going to be opening up the fixed update method. Now this fires every physics step, and because we're using physics, we want the camera to move smoothly with that slight damping effect. So we only need one line of code here, and this is what's going to be allowing the camera to move when we shoot. Because right now, the way everything was coded here, it wouldn't do that. And you might think, well, I could have put it right here, but that's in the update method, and it causes a bit of a choppy effect. It doesn't look very good. So we're going to be putting it in the fixed update and use time.delta time to make sure it follows the proper frame rate. It matches the physics updates here, okay, in the fixed update. So this one line of code, it's a bit of a long one, but we're going to take the transform dot position, so that's the transform position of our camera, and we're going to update it using a function called vector3.lerp. Lerp is interpolation. So how lerp works, we can say linearly interpolates between 2 points. So I'm going to enter in 2 points, and I'm going to control the speed of it by a float in the third parameter. So it does know exactly what I want it to do. Pretty close to what I want it to do. I don't want it to be target position. I want it to first take the transform position where it is currently located, and I want it to go to the target position, which is what we stored up above here in the update method. And then we're going to be taking time.delta time, but we're going to multiply that by the damping value. Okay, and that damping is what we wanted. Remember, time.delta time is the time it takes between frames. So to make sure this is consistent and looks smooth, no matter how fast or slow the computer is that's running this game. And the damping will, the higher that is, the quicker the camera follows. So 5 I found was a really good setting. Okay, that's our camera script. So a bit of a long one there, but it is one of the last bigger major scripts in this 3D game, actually. So we're going to let this update Okay, and we should be good to go. And you're going to notice what I first need to do is I need to update all these public. So I want the ball to be my player, pivot's going to be pivot, and focal point's going to be focal point. And then I can grab the ball here and drag it onto the golf ball controller because that's where that script is located. All right, let's press play. Here we go, and you can see the camera automatically offset it just by that amount that we talked about. Okay, so let's test a few of the functions here. If I hold the right mouse button, it's rotating, and notice we are rotating around that pivot. And if I use the scroller wheel, yeah, I can zoom in, I can zoom out. All right, and then let's give it a shot. Let's grab my ball, take a shot, and it's following the ball as I go. I can rotate while the ball is moving. I can zoom in and out. So let's take a shot and zoom. I'm zooming in. I can zoom out while it's rolling. I can then rotate. You'll notice when it's moving, and I press the right mouse button, it'll snap to it because it doesn't damp that. I tested damping rotation, and it was terrible. It was really finicky and choppy, and you don't want to damp the rotation. So everything looks way smoother if I did it like so. Okay, so there we are. Our camera has some great functionality now in this episode. It's going to follow the ball nicely, and I think this is going to look really good in all of our games. Or all of our golf holes. So I'll see you in episode 6, where we're going to finally start designing this hole and create a hole to score the ball in. All right, we'll see you next time.